There are several other objects in a database in addition to tables. With views, you can present and hide data from the tables. Many applications require the use of unique numbers as primary key values. You can either build code into the application to handle this requirement or use a sequence to generate unique numbers. If you want to improve the performance of data retrieval queries, you should consider creating an index. You can also use indexes to enforce uniqueness on a column or a collection of columns. You can provide alternative names for objects by using synonyms. A schema is a collection of logical structures of data or schema objects. A schema is owned by a database user and has the same name as that user. Each user owns a single schema. Schema objects can be created and manipulated with SQL and include tables, views, synonyms, sequences, stored procedures, indexes, clusters, and database links. If a table does not belong to the user, the owner's name must be prefixed to the table. A sequence is a user-created database object that can be shared by multiple users to generate integers. You can define a sequence to generate unique values or to recycle and use the same numbers again. A typical usage for sequences is to create a primary key value, which must be unique for each row. A sequence is generated and incremented, or decremented, by an internal Oracle routine. This can be a time-saving object, because it can reduce the amount of application code needed to write a sequence-generating routine. Sequence numbers are stored and generated independent of tables. Therefore, the same sequence can be used for multiple tables. After you create your sequence, it generates sequential numbers for use in your tables. Reference the sequence values by using the NEXTVAL and CURRVAL pseudocolumns. The NEXTVAL pseudocolumn is used to extract successive sequence numbers from a specified sequence. You must qualify nextval with the sequence name. When you reference sequence nextval, a new sequence number is generated and the current sequence number is placed in CURRVAL. The CURRVAL pseudocolumn is used to refer to a sequence number that the current user has just generated. However, NEXTVAL must be used to generate a sequence number in the current user's session before CURRVAL can be referenced. You must qualify curval with the sequence name. When you reference sequence curval, the last value returned to that user's process is displayed. You can cache sequences in memory to provide faster access to those sequence values. The cache is populated the first time you refer to the sequence. Each request for the next sequence value is retrieved from the cached sequence. After the last sequence value is used, the next request for the sequence pulls another cache of sequences into memory. If you reach the MAX-VALUE limit for your sequence, no additional values from the sequence are allocated and you will receive an error indicating that the sequence exceeds the max value. To continue to use the sequence, you can modify it by using the alter sequence statement. You must be the owner or have the alter privilege for the sequence to modify it. You must be the owner or have the drop any sequence privilege to remove it. Only future sequence numbers are affected by the alter sequence statement. The start with option cannot be changed using alter sequence. The sequence must be dropped and recreated to restart the sequence at a different number. Some validation is performed. For example, a new MAX-VALUE that is less than the current sequence number cannot be imposed. The user_sequences view describes all sequences that you own. When you create the sequence, you specify criteria that are stored in the user_sequences view. The columns in this view are sequence_name, name of the sequence, min_value, minimum value of the sequence, max_value, maximum value of the sequence, increment_by, value by which the sequence is incremented, cycle_flag, whether sequence wraps around on reaching the limit, order_flag, whether sequence numbers are generated in order, cache_size, number of sequence numbers to cache, last_number, last sequence number written to disk. If a sequence uses caching, the number written to disk is the last number placed in the sequence cache. This number is likely to be greater than the last sequence number that was used. The last_number column displays the next available sequence number if no cache is specified. After creating your sequence, it is documented in the data dictionary. Because a sequence is a database object, you can identify it in the user_objects data dictionary table. You can also confirm the settings of the sequence by selecting from the user_sequences data dictionary view. Synonyms are database objects that enable you to call a table by another name. You can create synonyms to give an alternative name to a table or to another database object. For example, you can create a synonym for a table or view, sequence, place, SQL program unit, user-defined object type, or another synonym. Because a synonym is simply an alias, it requires no storage other than its definition in the data dictionary. Synonyms can simplify SQL statements for database users. Synonyms are also useful for hiding the identity and location of an underlying schema object. To refer to a table that is owned by another user, you need to prefix the table name with the name of the user who created it, followed by a period. Creating a synonym eliminates the need to qualify the object name with the schema and provides you with an alternative name for a table, view, sequence, procedure, or other objects. This method can be especially useful with lengthy object names, such as views. Creating a synonym. The slide example creates a synonym for the department_sum_vu view for quicker reference. The database administrator can create a public synonym that is accessible to all users. Removing a synonym. To remove a synonym, use the drop synonym statement. Only the database administrator can drop a public synonym. The user_synonyms dictionary view describes private synonyms, synonyms that you own. You can query this view to find your synonyms. You can query all_synonyms to find out the name of all the synonyms that are available to you and the objects on which these synonyms apply. The columns in this view are synonym_name, name of the synonym, table_owner, owner of the object that is referenced by the synonym, table_name, name of the table or view that is referenced by the synonym, db_link, name of the database link reference, if any. An Oracle Server index is a schema object that can speed up the retrieval of rows by using a pointer and improves the performance of some queries. Indexes can be created explicitly or automatically. If you do not have an index on the column, a full table scan occurs. An index provides direct and fast access to rows in a table. Its purpose is to reduce the disk I/O by using an indexed path to locate data quickly. An index is used and maintained automatically by the Oracle Server. After an index is created, no direct activity is required by the user. Indexes are logically and physically independent of the data in the objects with which they are associated. This means that they can be created or dropped at any time, and have no effect on the base tables or other indexes. You can create two types of indexes. Unique index. The Oracle Server automatically creates this index when you define a column in a table to have a primary key or a unique constraint. The name of the index is the name that is given to the constraint. Non-unique index. This is an index that a user can create. For example, you can create the foreign key column index for a join in a query to improve the speed of retrieval. Create an index on one or more columns by issuing the create index statement. In the example in the slide, the create index clause is used with the create table statement to create a primary key index explicitly. You can name your indexes at the time of primary key creation to be different from the name of the primary key constraint. You can query the user_indexes data dictionary view for information about your indexes. Function-based indexes defined with the upper column_name or lower column_name keywords allow non-case sensitive searches. The Oracle Server uses the index only when that particular function is used in a query. You can create multiple indexes on the same set of columns if the indexes are of different types, use different partitioning, or have different uniqueness properties. For example, you can create a B-tree index and a bitmap index on the same set of columns. Similarly, you can create both a unique and non-unique index on the same set of columns. When you have multiple indexes on the same set of columns, only one of these indexes can be visible at a time. The code example shows the creation of a B-tree index, emp_id_name_x1, on the employee_id and first_name column of the employees table in the HR schema. After the creation of the index, it is altered to make it invisible. Then a bitmap index is created on the employee_id and first_name column of the employees table in the HR schema. The bitmap index, emp_id_name_x2, is visible by default. More is not always better. Having more indexes on a table does not produce faster queries. Each DML operation that is committed on a table with indexes means that the indexes must be updated. The more indexes that you have associated with a table, the more effort the Oracle Server must make to update all the indexes after a DML operation. When to create an index. Therefore, you should create indexes only if the column contains a wide range of values. The column contains a large number of null values. One or more columns are frequently used together in a where clause or join condition. The table is large and most queries are expected to retrieve less than 2% to 4% of the rows. Remember that if you want to enforce uniqueness, you should define a unique constraint in the table definition. A unique index is then created automatically. You query the user_indexes view to find out the names of your indexes, the table name on which the index is created, and whether the index is unique. In slide example A, the user_indexes view is queried to find the name of the index, name of the table on which the index is created, and whether the index is unique. In slide example B, observe that the Oracle server gives a generic name to the index that is created for the primary key column. The user_ind_columns dictionary view provides information such as the name of the index, name of the indexed table, name of a column within the index, and the column's position within the index. You cannot modify indexes. To change an index, you must drop it and then recreate it. Remove an index definition from the data dictionary by issuing the drop index statement. To drop an index, you must be the owner of the index or have the drop any index privilege. In the syntax, index is the name of the index. You can drop an index using the online keyword. Drop index emp_index online. Online. Specify online to indicate that DML operations on the table are allowed while dropping the index.